lucky. Shh.
Good morning, everyone. How are you? So groovy. All right, so we are nearly finished with our simultaneous equations, your favorite part of the year, wherein you've got algebra. Yay. I know you love algebra. Okay, just like this one here. See, I've got heaps of things from that you see everywhere else, just like these puzzles here, right? Because what we want to do today would be to translate some word problems that you would be able to turn into simultaneous equations. And after that, you'll be using the strategies that we learned, right, in solving these systems of linear equations. Okay, so these are puzzles. What do these mean? So from pictures, we want them put into words, right? For what we will be doing, they would be words that we want to convert into equations. So let's try some puzzles here first. First one, what do you think it means? Or any of those 6 boxes that you are able to solve, let me know and put on the chat or unmute yourself.
Oh, can you give us a hint?
I'll give you a hint. Well, this one's the easiest one. First, second, third time lucky. Who heard that? Third time lucky, right? So you can try and try and try again. Yeah. And the third tries a charm. That's what they say. So third time.
The third box.
I'm sorry?
The third box?
The third box is?
Yeah, a 4-leaf clover.
4-leaf clover. Clover. Right, it's a 4-leaf clover. Yay. Married for Charlize. I'll write that down because I will forget. I tell you, when you grow older, I said grow. Merit, you just forget things instantly. All right. Anyone else? So we've solved these 2 here.
Miss, I think I got another one. I think for the team with the I thing.
Team with the I is?
Is it, there's no I in team?
There's no I in team.
Oh. You can't say that. This is not funny.
It's not funny. How about these 3 here? These 3 are the ones that are left. What could they mean? This is so mathematical. I love this. Ooh, that's a clue. Right. What's this one here? It's not very clear, but this might give you a hint of what it means. What do you think?
Is that meant to be a fish or an infinity sign?
This fish. Yeah.
Oh, okay.
Fish.
So there's 4 different fishes in the compound magic.
Fish.
Fish for compliments.
Sorry?
I don't know. I don't get it, miss. Fish
get
for
it?
compliments.
It's what?
Why is the fish inside the 4?
If there's
fish for compliments.
You.
Oh.
I don't get it.
Oh, I had it in my head and then I lost it.
The words are there. It's fishing for
compliments. Oh, okay, I get that.
So that's fishing for compliments. Last 2 here. Hail. If you don't know what we're doing here, we're having fun in maths. We're figuring out these puzzles here, what these mean. So this one's third time lucky. Ashley said this is 4-leaf clover and there's no I in the team. What would these two be?
I don't know.
You might need to solve this for you to be able to, and then look at what it looks like when it's solved, for you to be able to solve it, to solve the puzzle. And Rocky's coming, I can hear his footsteps. He'll be barking soon, I tell you. It's his schedule. He's got a schedule. All right. Anyone? This is my hint. You've got there, and where is it located? Where is it located? Anyone? Rocky knows the answer. If you understand dog language. Did anyone figure it out?
Nope.
Nope. And what's that? Where is it? It's an inside job, guys.
Oh.
Oh.
Okay. And then the last one, you might need a pen and paper for that. So you'd need to write it down. 3i plus 1 is less than 2i plus 3u plus 1. And you need to solve it. So you need to expand these first, right? And then you have 3i plus 3 is less than 2i plus 3u plus 3. Yeah. And then you combine the like terms. Well, you can cancel out the 3 and the 3 there. And then you can combine the like terms. You've got 3i minus 2i gives you I less than 3u. And what does it look like? Is it obvious? No.
Miss, I got it.
What?
Oh, I love you.
Yay! We've solved all the puzzles. We could probably have a look at some of the translations we did previously from year 7 or year 8 or year 9. Okay, so these are the words that we use for addition, subtraction, multiplication, and division. So when you say sum, that's when you add them. So the sum of 6 and x would be 6 plus x. The number is increase. So when you see the word increase, that's adding. And in the same way, when you say decrease, then you're subtracting. Yeah. So maybe the one that might be a bit confusing for subtraction is when you use the word or the phrase less than. So when you have 3 less than a number, it's not 3 minus n, but instead it's the other way around. Yeah, it's n minus 3. Okay, but of course, when you say 9 minus a number, then that would just be 9 minus n. Okay. And then these are the words that you use for multiplication. These are the words that you use for division. There are heaps of other words that we use, but these are just some of the examples. Okay, so when we've got phrases, then we can translate them into expressions or mathematical expressions, just like if we've got translate each phrase into a variable expression or algebraic expression. You say 5 less than half of x. You would say what? 5 less than half of x, then that would be 1/2 x minus 5. Yeah. Or if we do some of these questions here, then we would have 5 more than a number, then that would be 5 plus x. The proper way would be to put it as x plus 5, but since it's plus, it doesn't matter. All right, it doesn't, the order doesn't matter. And then when you have a number divided by 4, you say n over 4. You don't use n then divided sign 4. You just use it as a fraction or write it as a fraction, n over 4. Okay, again, sum of 3 and a number would be n plus 3. Quotient, that means it's division. So the quotient of a number n 3, then you write n over 3. Okay, so these are probably the ones that we did in year 8. We did some of these as well in year 8 and in year 9, okay, but more in year 9. So just like these ones here, we want to match these sentences this time into equations. Okay, so let's have a look at those ones. It says 3 more than twice a number is 9. Which one is that? 3 more than twice a number. So when you say twice a number, what expression are we looking for? Multiplication. So twice a number in algebra or in algebraic expression, that means it's 2x, right? So you're multiplying 2 to x, so 2x. So 3 more than 2x means 3 plus 2x or 2x plus 3. So far, which one is that? 2x plus 3 is 9. So is the equal sign. So 2x plus 3 equals 9, right? So let's probably match them. 2x plus 3 equals 9 is this. Yeah. Oh. I didn't do that right, did I? Okay, and then what? 2 less than 3 times a number is 9. This time it's less than, so we're looking at the minus. So it's 2 less than 3 times a number. 3 times a number means 3x. So 3x minus 2, right? 3x minus 2 is 9. Therefore, it would be this one here. Yeah, that is hard. Okay, next. 3 times the number which is 2 less than x is 9. That's too long. Can't even say that in one breath. 3 times the number, so that would be 3x, which is 2 less than x is 9. What does that mean? 3 times the number 3x, which is 2 less than x is 9. So all of them is 9. 3 times the number which is 2 less than x. Which one is that? Is it this one? No, it says 2 less than x. So 3, I don't think they've done that properly, but I think what they mean is this: 3 multiplied to what does it say? 2 less than x. So 2 less than x is this, right? So 3 multiplied to 2 less than x. I think that's what they meant for that one. Okay, which is equal to 9. All right. People make mistakes and they did that very wrong. Okay, next. What would be the next one? 2 times the number which is 3 less than x is 9. So 3 less than x means 3 less than x is x minus 3. And we multiply that by 2. So it's this one here. Yeah. And therefore that's this one here. Okay. Where are we up to? 2 times the quantity 3 more than x is 9. 2 times the quantity 3 more than x. 3 more than x is where? 3 more than x, that's the one. So 2 times the quantity. So when you say quantity, that would be in brackets. So then you've got that as that one there. Yeah. And then 3 less than the product of 2 and x. 3 less than the product of 2 and x is 9. So these two here. And then you've got 2 decreased by 3 times a number is 9. 2 decreased by 3 times a number is 9. And therefore, it's that one there. And then hopefully the last one would match B, which is 3 times the quantity to decrease by x. So it should have been this one. 2 decreased by x. Did we do that wrong? 3 times a number, which is 2. Yeah. So we did that wrong. 2 less than, that one. So then, which one is it? This one here. Okay, and then that one there. Okay, hopefully all the rest are correct. Okay. Any questions about that or any objections? Or we can do the next slot. Let's save that. Okay, so you've got heaps of other ones there. 1/2 of a number is 4. So then that would be what? 1/2 of a number is 4. Let's quickly do them. 1/2 of a number, you've got half of x is 4, right? As simple as that. 6 less than a number is 9. 6 less than a number is 9. Yeah? Then you have twice a number is 12, more than 5 times the number. They're so silly. Twice a number, 2x, is 12 more than 5 times the number. Yeah? So now you can say, you know, another language other than whatever language, you know, who knows another language or can speak and read and write in another language. Yeah. So now you can say you can write maths or algebra. That's another language. 5 less than twice the number is 15. 5 less than twice a number is 15. And then 11 more than twice x is 5 less than x. I really don't like those kinds of questions. 11 more than twice x is 5 less than x. Okay, so again, you can swap these around, doesn't matter. Okay, if you wrote 2x plus 11, that should be the same thing. Okay, 11 plus 2x would be the same as 2x plus 11. All right, and you can do the rest for fun. Yeah, where am I? Okay, so if you need additional practice, you may also, I've forgotten if that's a video or, yeah, it would be a interactive one, so it gives you straight away if your answer is right or wrong. Okay, let's go back to that. All right, so we would now be looking at some word problems, applications of simultaneous linear equations. So what we did previously was to just focus on some strategies of how we solve them simultaneously, right? We've looked at the graphical method and we saw that the graphical method wouldn't be too efficient because one, it would use a lot of space in your book because you'd have to draw them and then graph them and then figure out what would be the intersection. And most of all, not all of these equations would have an intersection that would be perfectly plotted on the, like, at the corner of the grid, Okay, so you wouldn't be able to figure out or estimate properly what would be that point of intersection. Okay, and so we said that there are other strategies other than graphing which would probably be more efficient. Okay, and there were two strategies that we learned. The first one was the substitution and also the elimination, okay, which we did last lesson. So let's have a look at some examples here, and we've tried to translate some expressions into, phrases into expressions, and then sentences into equations. And from this one here, we would be able to come up with two equations. So that's our objective. Okay, so from these word problems, come up with two equations. And these two equations would each have two variables. Okay, so the first thing you want to do would be to represent them, write down what x is and write down what y is. Okay, so let's have a look at the problem here. It says Ashley received better results for his mathematics test than for his English test. If the sum of the 2 marks is 164 and the difference is 22, calculate the mark he received for each subject. So there are two things that we don't know here, which is perfect because then we would be able to represent those two unknown things. Okay, remember when we're solving simultaneous equations, there should be two unknowns, right? So the first unknown would be the mathematics mark, and then the second unknown would be the English mark. Yeah, so the first sentence here would probably be an important sentence because it says that the mathematics result would be greater than the English result, so that we know that x must be greater than y. And that's why when you add them, so it says there, if the sum of the 2 marks is 164, if you add x and y, you get 164, right? Now, when it's a minus, we don't know if we minus the y from x or x from y. But this sentence here tells us that the maths grade was better than the English grade, and therefore you would say that the bigger mark, or the number which is greater minus the number which is lower, would equal to 22. Okay, so these are the two equations that we've got. Okay, and I think for word problems of simultaneous equations, this is the most critical part, right, for you to figure out the right equation. And from here, you'd be able to solve it, simultaneously. Okay, so from the word problem here, again, it says the sum of the 2 marks is 164. So when you add these marks, you get 164. When you minus them, you get 22. So these are the two equations. Okay, are there questions so far as to how we got these two equations here? Yes? No? All right. Now, I think this one here, oh yeah, they did elimination method. So we can do that as well here. Just make that bigger. So we know that x plus y equals 164 and x minus y equals 22. Now we can add them together, right? When we add them together, the y's would cancel out each other, okay? Because then that's +1, this is -1, right? We said that when we add the opposites, they become 0, right? But when we add x and x, what we have would be 2x. That's equal to 164 plus 22 is 186. Yes, Rocky. And x therefore, goodness me, x therefore would be what? 93. Yeah. Now from here, then we can substitute the value of x into equation 1 or equation 2, whichever one you want. I'd probably choose equation 2 because I've got there a smaller number, although it's a minus, doesn't matter. So you've got 93 minus y equals 22. Okay, And therefore you can say that's 93 minus 22 equals y. And what would that be? It's 93 minus 22. That's 71 equals y, or that y equals 71. All right. So from here, because we said that the maths mark is larger than the English mark, then we know that this is the maths mark and that one is the English. Okay, or we could always go back to how we represented them. We said that X is the maths and Y is the English. Okay, so what you need to do for the last bit there, you say Ashley got 93 for maths and 71 for English. Okay, oops. Okay, yes. Kind of overwhelming. It's a lot because it's a lot of reading, a lot of translating, and then afterwards, a lot of working out as well. Okay. All right, let's have a look at the second example. It says there to finish a project, Genevieve buys a total of 25 nuts and bolts from a hardware store. If each nut costs 12 cents and bolt costs 25 cents, and the total purchase price is $4.30. Rocky, how many nuts and how many bolts does Genevieve buy? All right, so let's represent. What are we going to represent? We represent the ones that we do not know. Well, what do we not know about this problem? Or you could start with what you know. What you know is that there would be a total of 25 things that she bought. Yeah. So you could probably say, I would probably write N for nuts and bolts. And so I won't get confused later, whichever one is X and whichever one was Y. Okay, so N would be the number of, and then number of bolts. Okay, so what else do we know? We know that when you add them together, so now we're writing down our equation. When you add them together, you get 25 items, right? So that's our first equation because that's what it said here, okay? And then we've got, if each nut costs 12 cents and the bolt costs 25 cents, the total purchase price is $4.30, right? So if he bought N number of nuts, then he would be, or she would be paying 12 cents, right? 12 times N, right? She would have to pay 12 cents for every nut that she bought, okay? And then 25 cents, lots of B, is how much did she pay altogether? She paid $4.30 altogether. Okay, so that's those are the two equations that we're looking for. Okay, now we solve. What's our solution? Now, looking at these two equations, unlike the first one, wherein you've got the x plus y and x minus y, and you can simply add and subtract them using elimination, right? With this one, it's a bit different. Because then you won't have coefficients of N or coefficients of B that can cancel out each other if you minus or if you add them, okay? You could also multiply it by 0.12, but that doesn't look nice. It would look ugly, right? So what we could do would be to rename the first equation into saying that N is equal to 25 minus b. Okay, yes, does that make sense? Your equation 1, you can rename it to this one or rewrite it into this form, and they're the same. Okay, if you add two numbers, you get 25, then one number would have to be 25 minus the other. That makes sense, right? So now we can substitute the value or the expression 25 minus b into n, because we said that n is equal to 25 minus b, right? So then we can say 0.12 times by 25 minus b plus 0.25 b equals 4.3 or 30. Okay, and from there we probably need our calculator. What's 0.12 by 25? That's 3 minus 0.12b plus 0.25b equals 4.30. And we can combine these two because they're like terms, right? And if we combine them, what do we get? What's 0.12, negative 0.12 plus 0.25, or you can say that's 0.25 minus 0.12. That gives us 0.13. B equals 4.3 or 4.30, 4.3, doesn't matter, right? And we want to get rid of the 3 on this side. We have 0.13. You can minus both sides by 3, and therefore we get 1.3 here. And for us to get rid of 0.13, we divide both sides by 0.13. And therefore b is equal to what? 1.3 divided by 0.13. It gives us 10. What does that mean? What that means is that she bought what? 10 bolts. What is missing? What's missing is how many nuts she bought. So you could use that and say n is equal to 25 minus b, but we know that b is 10. Therefore, we now know that n must be 15. Yes? It's not very easy. Okay, so I've got there some other examples that you can use. Please watch if you need more examples before you attempt questions 1 to 10 of the work for today. Okay, and if you do get any questions, if you're stuck with any of them, please don't hesitate to message me and I'll reply to you straight away. Okay, well, here if you want to share your questions to others as well, it might be the same question that they've got and they're too shy to ask. Okay, so sharing is caring. So share your questions. Okay. All right. Thank you. And I'll stay online and I'll see you next week online as well.
Thank
All
you,
right.
Miss.
See ya. Bye.
Come on, Rocky, let's go.